So this is our center tap full wave rectifier circuit, for which we have to create the G code. For that, we are going to be, for our experiment, we are going to be creating two kinds of outputs. One is a edge cut output, and one it is the drill output. So actually the machine can perform three operations: edge cutting, milling and drilling. We are not going to be performing milling. Milling is going to be performed, the act of milling, which is removal of copper, is going to be happening using etching. So etching is another experiment, because of which, using the machine, we are only going to be performing edge cutting and the drilling. And these two operations are to be studied by you, not to be performed. Okay, so to start, to perform the operation of drilling and edge cutting using the machine does not understand the output of KiCad. The output of KiCad is Gerber. What the machine understands is something known as G code. So what we have to do is convert the Gerber files into G code files, and that is the reason why we are going to be using a software which is freely available online, which is known as FlatCam. Okay, so we will be using FlatCam in order to convert from Gerber. In case of edge cut layer, it is going to be a Gerber file which is going to be converted into a G code file, and in case of drill file, it is going to be an Epsilon drill file only, and it is going to remain as it is and directly get converted to G code. Epsilon drill file does not get converted to Gerber or geometry. So we will see that. So right now what we have in front of us is a PCB layout which is ready. We will try to check if it is giving us any errors or anything. Uh, Board clearance violation and remaining are all warnings. Okay, so board clearance violation, because it is saying that it should have um, this writing that we have has gone beyond. I'll just change the text size to even smaller. I'll make it 2. Edit. Because of which I'll again do Control B and B. I'll run the DRC again. So now you can see all of them are warnings only. So these warnings are all saying silk screen is clipped by solder mask, which is happening here. It's happening because I have increased the size of the pads everywhere. Why I have done that is because we are performing soldering by hand. We are performing for the first time, and we are not used to having very tiny solder pads. We are not proficient with our soldering skills, so I'm providing more area for us to be able to solder. Mhm. So this is our board. We have to create Gerber files first. Gerber files and Epsilon drill file. Gerber file for edge cut layer, Epsilon drill file for the drill layer. Okay. So uh, f- that for G code, plus we have to print this also. Hmm? I have to first remove the markers. So let us first create a PDF for printing. So to create the PDF for printing, what I usually do is, so that it does not get wasted, the paper does not get, glossy paper does not get wasted, I usually copy this and paste it, starting from, I can say I can start from here, because this is an entire A4 page, I'm guessing. Page setting, if you go to, you will see that it is an A4 size page. Okay, so I can take it to as much as I want. And now you have to ignore these connections that are there, air wires, just ignore them. And this arrangement that I'm doing is only for um, printout, huh? You can see that the sixth one does not fit, so I'll have to remove this. That's the reason why I better have this inside with more gap. Okay, done. Now you copy this and paste it. Okay, I'm deleting the original. Again, paste it. Again, paste, paste. Okay, I think 25 in number is enough. I could have actually increased the number a little more, but I think 25 is more than enough. Okay, so now I have to create a printout on glossy paper. So I will go to file and plot. So I will need to plot this. So instead of creating a Gerber file, because I want to print it out on a glossy paper, I will create a PDF. And I don't want any other layer right now. I want only edge cut layer. Sorry, not edge cut layer. I want only the back copper layer. My entire circuit is on back copper. So I will be selecting only back copper layer, which has to be printed out as a PDF inside this Gerber folder that is there in my project folder. Okay, so I'll say plot. These zone fields are out of date, but no, I don't want to refill them, because those have become out of date because I have created this printout formatting, which is not necessary for necessarily electrically correct. It is not electrically correct. It is not for the purpose of making a Gerber file. It is for the purpose of creating a PDF. Okay, so continue without refill. Okay, so the plotting is done. Let us just verify if that is done. We'll go to this experiment. I think this is the one that got created. Uh, the date is 14/11/2024, 5/11. Yeah, so this is the one that got created. Okay, so looks like everything is fine. Hmm. So this is what will get created. You can see how the soldering pads. This is not even 100% size. Okay, this is, now it is 100%. So you can see that the solder pads are quite big. So that soldering is correct. So to be exact, how big are the solder pads? This one edit is 3.5, and for the uh, resistor edit, this is 3.3. Okay, not even 2.5 and all. For the capacitor it is 3, and for the diode it is 3. So I have actually increased the size to quite a lot. Okay, so now that the PDF is generated, I don't need all of this. Now we are going to be generating the Gerber file in order to convert it to G code. Two kinds of Gerber files, not backcopper. Backcopper was for etching, so we have handled the backcopper for etching, um, backcopper PDF for etching, whereas Gerber file and the edge cut Gerber file and drill hole epsilon drill hole file is going to go for G code. Okay, so we have to first of all know the size of the circuit board eh, that we are going to be using in order to give the file to G code. So the size of the circuit board that I'm having in my hand is um, in centimeters. It is 15.2 centimeters. 15.2 centimeters by 15.2 centimeters. Yeah, 15.2 centimeters by 15.2 centimeters. That is the board that I'm having in my hand. So I need to have as many circuits as possible on one board. Correct? No. So what I will do is I will delete um, all of these. Just one copy is enough for me right now to decide how many I can have. According to me, by my past experience, 8 are enough. But I will first try to draw a rectangle in edge cut layer of uh, 15.2 by 15.2 centimeters, which is 15.2 by yeah, which is 152 by 152 millimeters. So I'm just drawing a rectangle of 152 by 152 millimeters. 150, 152, 152 by 152 millimeters. So this is how the board is, and inside this board I need to fit as many units as possible while making sure that the gap between the two boards is at least 6 mm. Why at least 6 mm is because um, I want the machine to edge cut. The machine bit is going to be 2 mm. So between two routes, or between two drill holes, or between two edge cuts, there is going to be one gap of 2 mm after one edge cut happens, and one gap of 2 mm after another edge cut happens. So for the second what you call it, ring, or second travel to happen, there has to be some kind of board in between. So I need at least 2 mm board in between two um, gaps, or two edge cuts that the machine is going to do. At least 2 mm in between, so total 6 mm. 2 mm for, so what I'm talking about is I'm talking about this here. Okay, so the machine will come here and edge cut, perform an edge cut of 2 mm. Then the machine will go here, perform an edge cut of 2 mm. To perform, if these two are too close together, it is like this the machine will already perform 2 mm, and to perform another 2 mm there is no body of the board only. And so while it is going for the second travel, the board will get bent or something, it will not perform as good. It has to go through uh, a body of board. So if there is no body on one side, then it is not going to perform. So I require some body in between. So 2 mm and 2 mm has to have some 2 mm body in between, 2 mm body of the PCB in between, so that the edge cut happens through the PCB, and not in between air and PCB. Okay, so so I need at least 6 mm gap between two PCBs vertically and horizontally, and I need at least I feel like 2 mm gap to know, because there are going to be clamps on the side. I will require at least 1 centimeter, one no, I think I'll keep 1.5 centimeters on top, 1.5 centimeters at the bottom, 1.5 on the left, and 1.5 on the right. Okay, that much if I keep, then I think I will have 1.5, so 15.2 minus 1 is 14.2. um, so then if I remove 1.2 on either side, it becomes 14. um, I think that is not enough, so I will make it a 13.5 board. Okay, so if I start from here, then I have to look for 135 by 135. It is not showing the measurements. I'll draw it again then. So if I start from here, I'm looking for 135 by 135. Okay, so this is the board inside which I can now nicely fit the PCBs. Move with making sure that now I can take it to as much edge as possible, but I have to have 6 mm gap in between. Okay, so I will just delete all of this. The thing is, this fellow, escape. uh, 6 mm means how much? If I keep here, what is the distance? So I'll go to measure tool, and I have to just find out what is the distance between these two boards. It's not becoming horizontal, but looks like it is around 40 mm. So much space I don't need because is the board size is max to max 47 mm by uh, 26 mm. 47 mm by 26 mm, and I'm having 135 mm, or say 47 is 4.7 centimeters, which is 5 centimeters. So I can't fit 3, so I will be able to fit only 2, and I don't need so much gap in between the two. So I will mm, okay, wait. I'll select the whole thing, and I'll deselect the board, and then I'll delete this. Okay, fine. Now I need to know the center. Now the thing is, um, we want to place this at the origin. You can't do that. We'll have to place it here only. We have no other option. Okay. So I have to find. There is no point finding the center as such. There's no point finding the center. Okay, fine. So I will uh, cut this and paste this as much. What is happening? Now I have to also see vertically. We realize that okay, I'm going to fit only 2 boards horizontally. How many boards am I going to be fitting vertically? Again, we will check the height. The height is 26.2, which means around 3 centimeters, and we have 15, so I should be able to fit, but a gap of 6 is required. So I have to have 15 minus 6, which is 9. That means I will be able to fit only 3. I should be able to fit at least 4. So we'll just see, control C, delete, control X, control V. How much space is that? Hopefully enough space. Let me check how much space is that. This is just 4 mm. I require more than this. 1 mm, I guess. 2 mm, 6 mm. This is 6 mm gap because the grid is 1 mm. Measure tool. This is 5.5 between, not edge cut, between the zone fill. So I'll select this and this. This is 6 mm. So I think that is enough. Just about enough. Um, yeah, I think it is enough. Okay, so now that I have made sure that this becomes, so I'm going to copy this now and paste such that there is, see, if I'm edge to edge meeting, oh, I think this is 1 mm, 1 mm, 2 mm, 3 mm, 4 mm, 5 mm, 6 mm. Okay. So you can see I can fit 4. That means I will be able to copy this and again zoom 1, 2, 3. Do it again. This is edge to edge fully. I don't know what is happening here. If it is underneath, okay, fine. 1, 2, 3, 4, 5, 6. But we have lots of width actually available. So why minimum 6? Let us move it further. 1, 2, 3, 4, 5, 6. Okay, so this is how the board is. um, this is the way that we are going to be doing the printing. Move 1, 2, 3, 4, 5, 6. Oops. No, why now I'm going to be removing this. This is not necessary. All that we needed to do was make sure that it fits inside the physical board size. So now I'm moving this as much towards the margin as possible, because we have to now convert this into a G code file. Okay, so what all layers are we going to be converted into G code? The edge cut layer and the drill, Epsilon drill. Okay, so first of all, this is the edge cut layer that we want to convert into G code. So edge cut layer has to get converted into, remember this sequence, edge cut layer, which is in PCB layout, has to get first converted into the Gerber file. Then the Gerber file has to get converted into geometry file. Then the geometry file will get converted into CNC job, which is a G code. Okay, so Gerber to geometry to G code. Now this from PCB layout to Gerber is going to be converted by KiCad. From Gerber to geometry, and geometry to a G code is going to be done by FlatCam. So now let us first convert for the edge cut. Let us convert this file into a Gerber file. File, no, plot only the edge cut layer, not the back copper layer. Now only the edge cut layer I want to convert into Gerber. Now Okay, fine. So I made a mistake while printing the PDF. So let us do that again later, not right now. Um, so while printing the PDF, I should have maintained the size of the. We will do it again now as soon as we finish this. So edge cut layer needs to be plotted as it is. We are not going to be making any changes in Gerber. Okay, so plot the edge cut layer. Any other changes? No. Plot the edge. Continue without refill. Hmm. Close. And to verify if everything is okay, we will go to Gerber viewer and we will go to file, open Gerber plot files. Gerber, the thing that we just plotted just now, which is the 527, 527. This or this? I need to see the type. Flat cam Gerber job file. I think I require the Gerber job file and edge cut. Let's select both and see what happens. Gerber job file cannot be loaded as a plot file. Huh. Okay, so this is the edge cut layer. This is the edge cut layer, so it is fine. Okay, we will go back to the PCB layout. Okay, so plot file is done. Now what I was saying is I will need to do this again because we have made a mistake while printing the PDF. Okay, but wait, I will complete the task of generating the, because the drill file and the edge cut file have to correspond physically absolutely accurately, otherwise misalignment will happen. So I will first try to create the drill file for this. Okay, so now again we will go to plot and we will generate the drill files, only drill files, so Exelon drill files. There is nothing that we have to do in this, just generate the drill files. Okay, Exelon, there is nothing, just generate drill file. So it will generate PTH and NPTH. We will require only pleated through hole. So close this. We will just verify if that is also done. So we will go to the project manager, go to Gerber viewer, file, open, and just verify if they are matching. Okay, open Gerber plot files. Gerber edge cut layer is the one that I just, no, edge cut layer is the one that I just opened. So this is the edge cut layer. Then I am trying to now search for file, open Exelon drill files that I just created. See, 1411 529, plated through hole, open, and I'm just verifying if everything is okay. Fine. So now I'm going to close this. Now I was just saying that my PDFs have not got created properly because the through hole that I've created, sorry, the hole of for all the pads are exact size. I don't want it to be exact size. Let me see if it is there. First of all, I don't remember. This is the one that got created. So holes are not there only. So it's good actually. Is it good or not? We should be having holes, but they should be small holes. If you see, there are no holes for us to recognize how to match, otherwise it'll become a problem. We have to have holes. So what we will do is, I'm just making sure that control C, control V. Move. this is plenty. Okay, this is what I will could actually plot more also. File, plot, PDF, only back copper, and drill marks small, not the actual size. Okay, now I can plot. Close. Now go back to the folder and verify. Now you can see that there are small holes that have come, so that we can identify them. Okay, so this is perfect. This is what I'm going to be printing out for today. Just one page is sufficient, I think, or maybe 2 pages, we will see. So yeah, so our job of generation, what all did we require? We required a PDF file for etching, we required a Gerber file for edge cutting, and we required a Epsilon drill file for drilling. Okay, these three files we required. So let us check if that is there, and then we will move on to flat cam. So this is what we created at just now, which is at 5:32. Then we have created the edge cut file and we have created the PTH. Okay, and we have verified that they are overlapping and correct. Okay, now the thing with Gerber files, these Gerber files, is that they are going to be getting flipped because our process of toner transfer is going to mirror it. The process, the actual physical process is going to mirror this. Whereas through hole, this drilling and edge cutting is going to be done by the machine on the backside of on the back copper layer only directly. So we should not be uh, we are not going to be flipping. Actual physical process of flipping is not going to happen, so we need to programmatically flip it. That is the reason why you have to remember that, should not forget that edge cut layer and the drill holes files that we have generated, we need to be mirrored and need to be symmetric around the origin. First of all, mirrored and symmetric around the origin, so that the machine does not have to move around too much. Okay, so that has to be remembered. Now let us close this. And so all the files that we need for the flat cam are there, so I'll close this also and close the KiCad. Now I'm going to go to flat cam. So open flat cam. Now is the actual process of converting the etching has already taken place. We don't need to worry about that. We only need to firstly worry about the um, edge cut, Gerber, and Epsilon drill files. Those are the two files. So file, open, open Gerber. We will go to edge cut. See, it is 52714, which is just now. Open. So this is the file. We will at the same time, because we are going to be performing flipping and centering it across the around the origin, let us make sure that the holes and the edge cut, the drill hole epsilon drill file and the edge cut layer, both are aligned. That's the reason why the flipping and making it symmetric about the origin we will do simultaneously, so that there is no alignment problem. So that then I will, you can see, as soon as I inserted the Gerber has come here. So I'll go to file, open epsilon drill file, and you can see npth here. I will open both those. Okay, so now the first job for us is to select both the layers. And how do you know that both the layers are selected? Is look over here. So you can see from here that both the layers are selected. Now you have to keep on reading this, whatever is written here. Right now it is saying PTH because it can write only one. You can't write two, but you know that both of them have got selected. Fine. So I want to now flip them. Okay, so go to, while they are selected, go to options and flip on x-axis. As soon as you do that, you can see that it is flipped. Okay, and this is how it should be. So a programmatical action of flipping, mirroring. Now select both again, make sure both of them are selected, and try to find out the origin here and mark what the origin that you have taken is, just for reference. Okay, so I am taking x coordinate as 66. If no, I'll take x coordinate as 67 and y coordinate as 76. Okay, we have to write it down somewhere so that we don't forget it. X coordinate origin, meaning when it appeared and after flipping, when we have imported it and after flipping, we had the origin at 67 comma minus 76, and now we are going to be moving it, right? No, so right click and say move. Then what it will ask is, if you can see the instruction over here, click on the start point. Okay, so I'm taking that start point as 67 comma minus 76. Click over there, and now you can see that it is saying click on destination point. So my destination point is center, so I'll click over here, and you can see that the entire, both the layers have come to the center of the origin, across the origin. Because of this, now the machine will have to move only this much in negative y, this much in positive, and in the four quadrants, only this movement. If say supposing all of this was here, the machine would have had to move around double the size in this direction, which is not right. So making it symmetric about the origin is always better. So now that this is done, these are the Gerber and drill file that we are going to be using in order to convert to G code. That's why it is important for us to now save this as flipped and centered. Okay, so I'm going to be saving this as edge cuts underscore flipped and centered, flipped and centered. Okay, and I'm going to go to experiment number 8 and 9, and I'm going to create a new folder so that I don't get confused. um, this is uh, G code generation on 14th November. Hmm. So this is the file name, and edge cuts flipped and centered, save, and PTH flipped and centered, save. Again here, flipped and centered, save. So these are the files that we have, that we are going to be working with. So now let us start the process of converting this Gerber file into geometry file and then G code. So to do that, you have to double click on the Gerber file, and because we know that this is an edge cut layer, which is the green one that we are talking about, the green edge cut layer that we are talking about, we will have to use the cutout tool. Cutout is specifically designed tool for edge cut layer only. So go to cutout tool. Now we have to know what all we need to do. Okay, ours is a panel type source object. It is, the source is GBR, so it is so we are talking about the source object. It is a panel and it is a Gerber, so we are using that Gerber. Then does not necessarily has a convex shape. If it is, it doesn't matter. So create a convex shape surrounding the entire PCB, used only if the source object type is Gerber. I have observed that this does not make much of a difference. um, I will not tick it, it doesn't matter. Now the tool diameter that I'm going to be using is 2 mm. Okay, then cut Z, I have observed yesterday I kept it as 1.8, and it went through the sacrificial layer, and it was quite a lot. And I measured the, right now also I'm having it in my hand, the PCB. The thickness of the PCB, if you measure in mm, you can see goes slightly beyond 1 mm. So I can say that it is like 1.2 or 1.3. I can take it as maximum 1.5. It is not even a 1.5 actually. So I will write minus 1.5, and if it does not go through and through, that's fine by us. uh, uh, we will manage cutting it. I have some other options also, but I don't want to um, I'll say 5 1 minus 1.55. Just I don't want the bottom, the sacrificial layer to get to suffer more. Minus 1.55 is more than enough. So that is the minus z that I'm going to be taking. How much deep is the drill bit going? It's going minus 1.55, because the uh, drill this thing, the PCB has a height of like 1.2 1.3 mm, FR4. So 1.55 is quite a lot actually. But I don't know what I should do. I will keep a sacrificial layer which will get sacrificed because of this. So fine, fine. It is not going to go through the sacrificial layer, so I'm happy about that. I don't want to do a multi depth. I don't want a margin because I want it ekdam cut to cut. So I don't want any margin. Then gap size, I decided that I want to have 3 mm gap size bridge, but I don't want to have four bridges. I want to have only two bridges, one at the top and one at the bottom. Or should I have left and right? Yeah, left and right. I should have top and bottom is because width is more, height is not that much. So width requires support. So that's why I will choose top and bottom. Okay, once that is done, all that we need to do is generate the geometry. So click on generate geometry, and as you can see, um, um, you can see that the difference between these two lines is, if you can see, is the same as the difference between the grids, and you can see that the grid is 1 mm. So you know that the difference is 1 mm, which means the drill bit, center of the drill bit is going to pass through this red color line. Center of the drill bit is going to pass through this center of the line, and here it is not going to pass. So here the edge cutting is not going to happen, it is going to create a bridge. Okay, and the drill bit is of 2 mm size, so 1 mm on this side and 1 mm on the above side, so total 2 mm is going to get um, uh, removed by the drill bit or get drilled away. Okay, and then we are having so much gap in between, and then again up till here will be drilled away, so there is some support for the drill bit to drill. Okay, and here also there is some a little bit of support, a little less support, because we wanted to fit four boards, right, vertically. That's okay. So more than sufficient is there in both the sides. So this is the board that we have created, and this is only the geometry. So as soon as we generate geometry, you'll see on project here, geometry has got generated. Okay, so let us save this also, because I don't want to work again. So here I will say Gerber, again 14, cutout geometry, the final geometry file that we have generated. Save. So our geometry file has got generated. So as I told you, Gerber has to get converted to geometry, geometry has to get converted to G code, which is the final file that we are going to be printing. Okay, so I'll double click on this, and you can see the geometry file. Now what we are doing is converting from geometry to G code. I don't want to edit the geometry at all. The geometry that has got generated is fine by me. I don't want to do anything to the properties. Just this, I feel like C2 should be used, because it will mention these are the tool tables, and somewhere I've seen that you have to write C2 here. Okay, so because of the kind of tool that we are using for drilling. Okay, so that is what we are going to be writing. Cut Z, which means how deep is it going to go. I don't want the cut Z of minus 2.4. That's why it was going through and through. here cut Z should be minus 1.55. I had done 2 over here, cut Z of 2. That's why it went through everything and reached the bed yesterday. Bed meaning the milling bed, the metal body. Okay, you should not have that much. 1.55 or 1.6 I guess should be more than enough. I think I'll keep it at 1.55 today because I've seen what happens yesterday. Travel Z is only 2 is not, I'm not happy. I was very worried that it is just about 2 millimeters above the surface while traveling. I would like it to be a little more, so I will say come at least 5 on top while you are traveling. Feed rate I can't change, this gets overridden. Um, spindle speed, we are not feeding, right? We are not feeding anything. Spindle speed I can't control, that is one fixed spindle speed. Dwell time also I can't control. So the items that I can control are cut Z and travel Z over here, which I'm setting to minus 1.55 and 5 then end move, if you're changing, I'm not going to be changing tools in between. So end move I'm going to make end move I will make 15 is fine. Yes, that is okay. So those are the settings that I will do, and say generate CNC job. Okay, as you can see, this is the CNC job. What you can see over here are yellow places are where travel Z will happen, which means it is going to be traveling, it is not going to be drilling. And blue lines is the place where it is going to be actually performing the drilling. So you can see it is going to start, where is one, this is two. So it starts from the origin, one, then it will go to two, then it is going to go to three here. So you can't see the yellow lines because it should be, anyway, then it is going to go to 3, then it is going to go to 4. It has its own algorithm. Okay, so then it is going to go to 4, then 5, then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Then it is going to go on this side 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, and once it finishes, this is the 32 ring that it will finish, and then it will come back to the origin at 15 height, that is the end Z that we have chosen, and it will stop. So that is our G code that has got generated from this. That is the file that we should save. So save CNC file. This is the file that we are going to be loading on the controller software uh, of the of the machine, which is Wegstr, controller software of Wegstr machine. Fine. So here now I'll save this as underscore G code. Actually, I don't have to do it. It is dot nc, but I will still write this as G code. So finally, we have generated the G code for the board. G code is done. Now we need to do the drill files, Epsilon drill files. Okay, so let us go back here and we will open the what you can do is, because this work is done, the geometry file is done, I can right click and disable plot. I don't need to see that geometry file, which is that line that was there. It is gone now. You won't be able, the red line that we were seeing outside the rectangle, that I don't want to see. For that matter, I don't even want to see the original green color rectangles, so I will disable. Then I don't even want to see the CNC job that has got generated, which is that blue and yellow lines. Those also I don't want to see right now, because I've worked, I've finished, and I've saved the job also. So disable plot, I'm just disabling, I'm not deleting anything. So now we are going to be dealing with the drill holes. So the drill hole file, we will try to check. So you can see over here that we have multiple different sizes of holes, which means it will require tool change. Okay, but to keep things simple, it is possible to change the tools. um, just that for such a simple circuit, we don't want to get involved in a tool change. So supposing it was a very complex circuit where it was extremely important that we need a tool change, and that much of spending that much time is justified, then we would have done this. But just for a center tap full wave rectifier, for which we have decided, we have managed to have pad size so large, 3 mm, taking in the largest size of the hole over here, to understand that we will have to go to KiCad, and then we will understand what is the largest size. So the largest size is corresponding to these screw terminals. Okay, so you edit to see the properties. The largest size of the hole is 1.3. 1.3, that means I require a drill bit of at least 1.3 or more than that. Okay, so the one that is available in the lab right now is 1.41, 415 actually, 1.415. So which means that I'm going to be drilling so this is actually 1.3 diameter. I will be drilling 1.4 diameter, but all of the pads that I have are at least 3 millimeter, at least 3 millimeters. So um, uh, even if I remove 1.5 out of it, 1.5 diameter will still remain for as an area available for soldering. Okay, so it is fine. But the problem that happens is the smallest one over here is going to be of 0.8, which I think corresponds to, let us see what. The 0.8 corresponds to, I think, the capacitor 0.8. Let us check. Diameter is 1 mm. The smallest one is which one? This one. Smallest one is this, because it is flipped, right? So it was looking on this side, it was seen on this side, it is flipped, so actually it is this one. So if I edit, see 0.8, which is the um, which one is this? This is the resistor. The resistor has 0.8, correct. So that means I'm going to be making holes of 1.415 mm, and the resistor terminal has 0.8 mm diameter. The terminal, the pin itself has 0.8, which means there is going to be a gap of 1.415 minus 0.8, 0.9, 1, 2, 3, 4, almost like 5.5 mm, 0.515 mm gap is going to be there, which has to be filled by solder. Okay, so if we have to have good um, design capabilities or good thought process to make sure that we put enough amount of solder, so that there is no gap between the pin terminal and the soldering pad which is going to be there. So we just need to handle it. We will see that during hardware session. Okay, so that is the biggest problem. Once that is solved, now that you know what the problem is, what we will do is we will not get into tool change for various pin sizes or various hole sizes. We will just set the tool diameter to 1.415 mm, which I have, and I will change the hole size, all of these hole sizes to that. Okay, so that is our motive. So I'm going to this the double clicking on this drill file that we have, Epsilon drill file. Double click on this, and we will see um, the the details about how many holes or what all kinds of tools we require, and how many drill holes will have to be done by that tool. So this information is for the entire 8 boards. So for 8, we have 16 holes of 8, which is, see, 1 2 3 4 8 on this side, 8 on this side, 16 holes of 0.8 for resistor, 16 holes of 1 mm I think for the capacitor, 32 holes of 1.1 mm I think for the diodes, and 40 holes of 1.3, which is 5 per board, so 50 40. Okay, so those are the number of holes, but I am not going to be using all of this, changing all of this. So I will say um, 1.3 size. Even though if I'm mentioning 1.3 over here, I'm going to be putting 1.415 bit. Okay, because that is the bit size that is available to us in the lab, and it is okay. Um, it's fine. We can write 1.4 over here. Fine, I'll edit it to make 1.4. So to do that, we have to go to Epsilon editor. Okay, so in Epsilon editor I will write 1.4 and change this also to 1.4. Oh, editor, change this also to 1. Oh, what is happening? 1.4, and then change this also to 1.4. So as you can see, all of the 104 holes have now become 1.4 holes. Okay, so I am going to be using this. Okay, so exit editor, yes, I want to save the edited object. All of them are of the same size now. Okay, so what you are seeing is a plot of two things. If you can see, um, there is a original version and there is an edited version. Okay, I don't want this version, so I will right now save this first, the edited version, because that is the one that I want to convert to G code. So I'll save this and I will call it edited um, equal holes of 1.4. Save. So now that it is saved, I'm just going to disable this because I don't need to see that. So now all of the holes are the same, and this is the file that I want to convert into a G code now. Okay, so epsilon file does not get converted to drill file does not get converted to geometry. Only the back copper gets to geometry and the edge cut layer. The Gerber files get converted to geometry and then geometry to G code, whereas the epsilon drill files directly get converted to G code. Okay, so double click on this and then go to the drilling tool, and here in drilling tool you can see that we are going to be using that 1.4 diameter. Cut Z, again I don't want a cut Z of minus 1.7, I want minus 1.55. 55 is what it is, not taking 55. Fine, then I'll write 1.6. I don't know, I will just make sure that sacrificial layer is at least um, boards 2 boards thick. mm, this I don't want to take a risk with, so uh, I think I'll go for 1.6, 1.56. No, 1.56 is taken, 1.55 is not taken, it's taken. So I'll write it as 1.55, which we have. So there is no multi depth. Travel Z, I decided at least give me 5 mm of travel Z. Then feed rate is out of our control. Spindle speed is also out of our control. Offset Z, I'm not going to do anything. Tool change at 15, but we are not having any tool change. End move, XY, all of this is fine. So this is our, so all that we need to set is cut Z at minus 1.55 and travel Z at 5 mm, positive 5 mm. Okay, so yeah, so this is fine. So I will now generate the CNC job, and you can see that the CNC job has got generated. Okay, so which means you can see as the brown is where it is going to drill through, well, where the drilling will happen. And if you can see, it is going to start from the origin, it is going to go here. This is the algorithm, best algorithm to reduce the optimize the time utilization as fast as possible. So you can see it is going to go here, then you're going to come here, complete all the holes 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 here, here, like this it is going to go, and go on drilling. And then it is going to finally, after finishing here 105, then it will come back to the origin at whatever height was mentioned. Okay, so this is the G code that has got generated. We will save this G code. Although it is .nc means it is G code, I'll just write this as G code. Save. I I think it should have been G underscore code. I don't remember. Save. So yeah, so now we will go back to our project and we will just observe the G codes that we have generated. I will just hide this is not necessary. Disable plot and enable plot. So these are the two G code files that we have generated for the machine to perform firstly edge cutting and secondly hole drilling. Control S. I'll just save the project. Fine. Mm, Center tap, full wave rectifier, G code gen for for um, edge cut and drilling. Save. This is the project and I'm closing this.